So in previous session we spoke about and also discussed about the Golang strings, actually fundamentals of Golang strings, how it works, how the concatenation and other optimization techniques we can use since it is immutable things. So now we'll try to solve one of the leet code problem, which is like a longest substring without repeating characters. The problem is very straightforward. It's easy to understand. So we need to given a string of find the length of the longest substring without repeating characters. For example, one ABC, ABC, BB. Here actually ABC repeated. So if you take the unique strings, ABC is the unique characters which has length 3. Okay. So yeah, in second example, B repeated many times. So the length of the unique longest substring with non-repeating characters is 1B. Yeah. So this problem we can solve in two ways, uh, basically many ways. But what I want to express here is like try to solve this problem with brute force first, and then we'll try to uh, implement optimized one. So brute force approach basically whatever the string we have, we got it. Let us take not a big string. We can take the small string. Okay. So basically we'll try to take A, B, C, D. So in this string through brute force, we need to split this particular A, B, C, D into how many combinations of the substrings we can form. We can take like nested loops to divide this particular string into all combinations of substrings. For example, yeah, in first case actually you can take A, AB and ABC, ABCD. So this is the first division where the position I will be 0 and J will move forward actually. So now when I become, let me type here, I equal to 0 and J start from 0 and go on to N. So here in next case like I equal to 1 and J start from 1 to N. In this case if you see it will start from B, next BC and BCD. Okay, so this particular three things. So when keep moves actually when I equal to 2 and J start from 2 to N. In this case you will see C and CD and keep moving. Now I equal to 3 and J will keep moving. In this case actually you will find only D. So you will get like all combinations 4, 3, 7, 9 and 10. 10 different strings, substrings you will get, out of which you need to find which is the non-repeating substring with unique characters. I mean non-repeating characters substring. So that will be 4 here. Okay. So to divide this actually it will take O of n square. I will write this code for you. And also to make this particular substring has unique characters or not, this also will take O of n time complexity. Basically total actually O of n cube it will take. This is the worst case. And also some space, maybe O of n. This is the worst case brute force approach. Okay. Coming to same problem with by using extra memory, optimized solution could be we can take map to store index of the characters, basically wherever position, for example A will be there, and if it repeated then it will be this particular position will be changed to new index. So we will use this index as a left index and keep moving, and we'll try to start the unique character length from this particular character, and we'll take it forward, and we'll try to figure out. This will be like O of n time complexity per time and O of n per space as well. So we'll discuss more about these things during writing the code for this. Okay, we'll write the both the solutions now anyway to understand more clearly. Cool. So yeah, we'll try to see that max length could be 0 initially. Now we'll try to find the all combination of substrings. What we can do is, let me get length of s. We'll try to see the combinations of all strings, like for example, we'll take the brute force approach. I equal to 0, I less than n, I plus plus, and for j equal to I, j less than, j is less than n, j plus plus. Okay. Now we'll try to write one more function. Let me write that. Let me write here only. We'll try to write this function all unique. This will take string and start position and end position. Okay. If this is true, then we need to figure out the max length is less than j minus I plus 1 or not. If this is the case, then max length will be j minus I plus 1. So this function we'll try to implement now. This function just take the string and starting and ending position. It will return all characters are unique or not. So all unique, it will take string s and start and end position of type integer, and it will return boolean. Okay. Now we'll try to use the map to for the convenience to check the character as repeated or not. I will try to create a map of byte and boolean, basically for if that particular character exists or not. Okay. So now what we will do is we will try to iterate from start point and should be end position I plus plus. So we will try to see, okay, map of s of I, if exists then return false, otherwise return true. And also we need to do one more thing here, map of s of I equal to true, since we already see this particular thing. Okay, that's it. Let me run and see any problems are there. Yes, return max length. Yeah, so this is the brute force approach. Okay, and let me try to implement the other solution, like whatever we spoke about, the optimization, that is of intent complexity. So again here we will get the length of string, first thing, and also ML max length could be 0. So we need to create a map as well. Here actually, as I mentioned, we need to take the index, make map of byte, and will be index will be the integer we'll take, and also we'll take left position. This will start from 0. So now these are the required variables, and for now we will start from right, that equal to 0, and right could be less than n, and right plus plus. We'll try to increment this. Here we will try to see the if index and value, value means value of the position, map of s of right. So if this is the case, v should be valid and I should be greater than or equal to left. In this case, actually we'll try to increment the left position. This means like the repeated character we found, and the index of the position in the given string is actually greater than or equal to left. So we'll try to change the left position from the I position plus 1. Okay, that means new substring will start from that particular position. Okay, after that what we can do is we can try to update the map of the right character with the index. Okay, and the current length could be right minus left plus 1. Now we will see if max length is less than current length, then max length equal to CL, current length. Okay, I think that's it, and we can return the max length. Okay, it is actually compiling and working good, and if you run this it will work. Okay, so that's about this. Actually here we can see there is a O of n space and only O of n time complexity. Okay, thank you.